So our cerebral blood vessels are very responsive to elevations in arterial carbon dioxide or hypercapnia. And when those brain blood vessels are exposed to hypercapnia, they vasodilate and thus brain blood flow increases. And the degree to which brain blood flow increases with hypercapnia can serve as an index of cerebral vascular function, which has implications for stroke risk, Alzheimer's disease risk, among other conditions. Now, this systemic hypercapnia that I'm referring to can be achieved through a variety of methods, including rebreathing-induced hypercapnia or end-tidal CO2 forcing or targeting, along with, as we used in this study, delivering a fixed inspired concentration of carbon dioxide. Furthermore, there are a variety of methods to measure the increase in brain blood flow during hypercapnia. Traditionally, researchers have relied heavily upon transcranial Doppler ultrasound. However, this method has an inherent limitation in that it doesn't allow you to quantify brain blood flow because blood vessel diameter cannot be measured. Thus, many researchers have begun using duplex ultrasonography of the internal carotid artery because it allows you to quantify blood flow by measuring not only blood velocity, but also blood vessel diameter. And this can help give us a better overall picture of cerebral vascular function. However, to our knowledge, the repeatability of these end-tidal CO2 and ICA blood flow responses during steady-state hypercapnia have yet to be evaluated. Therefore, in this study, we brought in 6 young, healthy participants to perform the test. And they were aged around 21 years old. They were a mix of black and white individuals, and they had normal, healthy BMI, heart rate, and blood pressure. So we had them come in for 3 steady-state hypercapnia tests. They performed 1 trial on one day, and then 2 trials separated by approximately 15 minutes on another day. For the experimental protocol, we instrumented them with an ECG to measure heart rate, a pulse oximeter to measure SpO2, and we measured beat-to-beat blood pressure using finger photoplethysmography. To measure PET CO2, we used capnography, and then to measure internal carotid artery diameter along with blood velocity, we used duplex ultrasonography, and thus we were able to calculate blood flow. For the experimental protocol, we first measured resting baseline values for 3 minutes, and then proceeded to administer 6% CO2 for 3 minutes. For the analysis, we use intra-class correlation coefficients, and these are depicted in the Bland-Altman plots, figures 2 and 3. Now, figure 2 shows us the repeatability of the delta PET CO2 response. And you can see here on the x-axis that it is an average of the 2 trials for the between visit or within day repeatability. So the y-axis shows us the difference between trial 1 and trial 2 for each participant. And as you can see, the between visit repeatability was excellent with an ICC value of 0.94. However, the within day repeatability was moderate with an ICC value of 0.64. Moving to the blood flow response during hypercapnia, we have the same setup. And when we look at the x-axis here, we have the blood flow average between 2 trials in milliliters per minute. And on the y-axis, we have the difference between trial 1 and trial 2 for each participant. And here you can see again that the between visit repeatability was excellent with an ICC value of 0.91. However, within day repeatability was only considered good with ICC value of 0.74. These preliminary data suggest that between visit repeatability of delta PET CO2 with 6% hypercapnia is better than within day repeatability. And as far as the blood flow response goes, these preliminary data suggest that ICA blood flow during steady state hypercapnia is good to excellent.